Hi, everyone. I'm excited to take you back to basics and get you excited about applied machine learning today. But before we get any further, have you ever had that moment when you realize everyone is using some word and you have no idea what it means, but at this point you're too afraid to ask? What even is machine learning and AI? Well, contrary to popular belief, it is not a magical box of magic. Instead, let's put it bluntly so we can all get it. It is a thing labeler, essentially. Yeah, that's what it is. It's a thing labeler that uses examples to label things. So, why should you be excited about this thing labeler? Well, here's a photo of my pet Huxley. And when you look at this, you've taken in some pretty complicated information through your senses, and you just know that that's a cat, as if by magic. And if I show you this other one, you're not fooled. You still know that that's a cat, even though the images are completely different. Now, imagine that you wanted to get this thing labeling task automated. In the old days, you would have to take that standard traditional programming approach. Anyone here programmer? Yeah, okay, a few of you, so you know how this works, programmers. What you actually do is you communicate with the universe, right? You think really hard about your problem, and then you have to come up with the recipe that connects all those pixels with the label cat. And then you handcraft that recipe. So you are explaining yourself with instructions. Now, in machine learning, you don't explain with instructions, you explain with examples. Because think about it, what are those instructions? What did your brain do with those pixels? Can you tell me how you turn those pixels, those colors, into the word cat? What precisely did you do with each pixel? You don't know, do you? Your brain just has the benefit of eons of evolution, and now it just does it, and you don't even know how it does it. So how could you possibly express yourself with instructions? You don't know what those instructions are. Wouldn't you rather just say, hey, machine, here's a bunch of examples of cat, here's a bunch of examples of not cat, go figure it out yourself. That is the essence of machine learning. That's what it is, where you explain your wishes to a machine, not with instructions, but instead with examples. Now, what is AI? Well, let's be frank. Right now in the business, people tend to just use AI and machine learning interchangeably, and I don't actually mind that so much, because when AI was named, that was the days when this was more hype than happening, as it has been for a really long time. And it was an aspirational sort of name, artificial intelligence, and it was supposed to encompass everything. Whereas what we mean today when we say those words AI, what we're really referring to is a narrow part of machine learning called deep learning. And so really, if you understand about machine learning, you also understand about AI. All the principles are the same, so let me take you behind the scenes. How does machine learning and AI work? Why should you be excited about it? Well, first off, you should be excited about it because of this. Sometimes the instructions are so complicated, you cannot possibly come up with them by hand. Can't be done. You can't think them up. They are, in other words, ineffable. Machine learning and AI, they are about automating the ineffable. It doesn't matter that you cannot say how to do it. You can still get the machine to learn it anyway, because you're going to use examples. This is really powerful. This is a whole new direction, a fundamental leap. And it's just an alternative programming paradigm, but it's a leap in technology. Because all those tasks where you could not say how to do it, you can automate them anyway. So get excited about automating the ineffable. But let me show you how it works. To understand how it works, come into the kitchen with me. I have an analogy for you. I'm going to show you how these things play out. Whoops, I think that's me. Ingredients, appliances, recipes, and dishes, or the fancy words that you might use, data, algorithms, models, and predictions. Let me show you how this all plays out. So first off, you grab some ingredients. And your entire goal, because this is thing labeling, is to separate the triangles from the circles. Can you do it? Well, you're thinking, hopefully, of putting some kind of boundary between them, right? Like put a line between them, sure. That is what an algorithm does for you. Now, what the algorithm does is it figures out where is the best place to put that fence, that boundary. And I hope you see that straight across is kind of a dumb idea here. With these ingredients, a better placement would have a slope, as you see there. Now, you don't have to use a single line. Your boundary between the labels can have all kinds of shapes. It can be made of multiple vertical and horizontal lines. It can even be a really squiggly thing. So when you use this neural network algorithm, that's where you're asking it to put some squiggly shaped thing in between, and then you would be doing AI. Now, when this thing is finished figuring out where's the best place to put the boundary based on your ingredients, what comes out is what you've wanted all along, which is a model. What's a model? It's just a fancy word for recipe. The recipe that you're going to use to convert your new input into the output or dish that you're going to serve your customers. So in this case, what are we saying? Is this a light yellow circle or a dark yellow triangle? I would say this is the circle up there. Okay, now back to our analogy. Can I see a show of hands, please? Who here knows how a microwave oven works well enough to build me a brand new one from scratch? Any takers? Who can build me a microwave? No one. Okay, different question. Who here has never used a microwave to cook food? Anybody? Anybody? So both times, no hands. You've just told me, one, you have no idea how microwaves work, yeah? And two, you all use them. Why do you trust these microwaves? You don't know how they work. Well, you're not going to trust them by reading the wiring diagram, are you? You're going to trust them because you're going to know what you're expecting them to do for you. And then you're going to check that they deliver. In other words, you're going to think about what you're trying to cook, and then you're going to look at what comes out of the microwave and make sure that that is what you wanted, and you're going to taste it. You will approach machine learning exactly the same way. Now, what they don't tell you is that there are actually two different disciplines when you hear about machine learning and AI. And these two disciplines, they are as different as building microwaves from scratch and cooking with them to innovate in the kitchen. The one that is the traditional one that most of the university courses are about is about building general purpose tools, microwaves, for other people to go and use. And so you don't know what they're going to cook with those things, but you are just building a microwave that's a better microwave than the previous one that works on the moon in zero gravity or what have you, right? You're innovating in microwaves. And the university courses, they are a long, many years study path. Because to build a better microwave than this one, of course you need to know how this one works. How are you going to build a better one if you don't understand this one? So of course you need all those years and all those university courses. But let's face it, many of you, you don't want to know how that microwave is wired, and you don't want to build a new microwave. You're in a different business. You want to just get cooking already and at industrial scale. What you are looking for is the applied side, or what we at Google are calling decision intelligence. This is about using microwaves that exist already to get things done, to solve real business problems. Now the thing is, you can do this without knowing how the microwave is wired, just as you know how to cook with microwaves without knowing how they're wired, but there is so much more that you do need to know. If you want to open McDonald's at scale, Just because you don't have to build your own microwaves doesn't mean it's easy. You have to worry about the quality of your ingredients and how to get all those ingredients at scale and how to check them, how to figure out what your customers want, how to make sure that what you're delivering for your customers is what you've needed all along, and how to actually tinker, innovate, and play in the kitchen if what you've said is, I want to make a sock that tastes like pizza and is edible. That's a different process from building a new microwave. Now, here's the reason that businesses fail at machine learning. They don't know what business they're in. They want to innovate in the kitchen, but they hire people to build them microwaves. Those are two entirely different disciplines, my friends. And so what I see people doing is they want to open their industrial scale kitchens, they want to apply machine learning, and instead they go and hire themselves a team of 20 PhDs who have been building microwave components their whole lives. What could possibly go wrong, right? Well, if it doesn't go wrong, that's because you got lucky and you hired yourself some engineers who just happened to be great chefs, who studied how to build microwaves their whole lives and then learned about cooking later on. As our site reliability folk at Google like to say, hope is not a strategy. Hoping that this works out for you, that's not the way you want to go about doing this. Instead, you want to start with an applied focus. And you want to realize that there are warehouses of these microwaves. If you don't need to build them, don't build them, grab them and start cooking with them. And worry more about the other things. What are you going to build? How are you going to check that it's good? So I want you to rethink tradition to decision intelligence from traditional AI, unless you are in the business of building general purpose machine learning tools. But why now? Why is the world getting excited about this stuff now? The algorithms have been around for ages. Deep learning, that thing you're calling AI, that's a child of the 60s. The reason that it's possible now is really a story about the cloud. To make these things tick, you need ingredients at scale, and you need to be able to process them. So you need the computing power to do that. The world's collecting a lot more data now, and the cloud means that you don't need to build your own data center to try out playing with the data and making machine learning and AI solutions. You can just borrow someone else's data center and have a go at it. And it also means that if you're a smaller player, you can also get into the game and you can start getting creative. And the tools are getting easier. That's another really important thing. With access to easier tools, you can have people who didn't train in AI and computer science and all those advanced things their whole lives participating in this space. Super exciting. And something I'm really excited about is Google Cloud BigQuery, which is a tool that really exemplifies these three things. And you should get excited because it is launching here in your region when? Next week. So it's going to be here. And what is this thing? This is our enterprise grade tool for looking at massive, mind-boggling data set sizes and giving you instant gratification. And it even has inbuilt opportunity to do machine learning without having to export your data and move it around and take it elsewhere. So you get everything in one place at massive scale. It's beautiful, super exciting. What this all means is that the future is here. This isn't just science fiction anymore, the way it was in the 60s, 70s, 80s, 90s. It's here today, and it's solving real problems. And this is just a small set of the cloud customers that we have. Now, what you need to focus on if you're going to cook with that microwave are two things. What are we going to cook? How do we know it works? So let me take you through that. How do you think about finding use cases? Simply remember that it's thing labeling using examples. So let's look at some thing labeling opportunities. You could manage operations using this. So I'm going to show you real examples. And we did this at Google. We gave AI control of one of our data center's cooling systems. The label is where to set that thermostat, essentially. And when it had control of this, it reduced the carbon footprint, or rather I should say, it improved the energy efficiency of that data center by 40%. Data centers are expensive. That's a huge amount of money saved, but that's also a huge carbon footprint reduction, so it's great for the world. Other types of labels. All over customer service, you have effectively labels. What is the sentence that comes out when someone is speaking on the phone to your customer? What is the particular option that is served to them when they log in? Those are all labels, and when you think about those as labels, you can use data to improve serving them. Personalizing experiences. Which of a series of experience paths should you give this one individual user? That is also a label. And that is also something you can apply AI to. Predicting risk. What's the probability of something? What's the probability that this particular one is fraudulent? All labels. How much is this claim going to be worth later on? That's also a label. And you could think about estimating that from a photograph. All of this you can do with machine learning and AI. Just think of it as labels. Now, how do you avoid pitfalls? I make it sound really easy. What's the part that's going to get you? It is when you forget the basics of learning and teaching. So I want you to forget about magic. And just think of this in terms of what's reasonable and practical with a human student. First things first. What keeps you safe is testing. If your student says to you, I can do calculus, do you trust them? No. What do? You give them an exam, and that exam should be carefully designed to check that they can actually do calculus. Now here's the big pitfall. If you give your student a textbook, and a textbook is a data set, right, with examples, and those examples all have right answers, that's inputs and outputs, like the data that you're going to use. So you've got a textbook, you give your student the whole textbook to study from, and then you ask that student an exam based on problems in that same textbook. You see the gotcha, right? How are you going to know if your student actually understands, or if they have just memorized their way to perfect scores? Well, you've got to catch memorization. When you hear overfitting in machine learning, that's just memorization. The way you catch it is you give them examples they've never seen before, and a rich enough exam that really represents what you care about your student understanding, that represents the environment where your student is supposed to operate. And if they pass that exam with the new examples, then you can trust them. So it's testing that keeps you safe. And use relevant examples. If you want a student that is calculus enabled, please don't give them textbooks that are filled with Japanese-English vocabulary pairs. That's not going to be effective for teaching calculus. So please make sure that your examples are actually relevant and that they represent the world that you want your system or student to succeed in. Holds for humans, holds for machines. Same thing. So I recommend that Google engineers actually tattoo this sentence on themselves if they're going near machine learning. The world represented by your data is the only world that you can expect to succeed in. So please open those data sets, those examples, and make sure that they are appropriate, that they represent the task that you want your student to learn. Those are the hardest parts. But they're easy if you just keep in mind these basics of learning and teaching. And I want to point out one more thing about your human students. You have no idea how they do the calculus. You don't know how the brain implements calculus. So why do you trust them? Not because you're going to take a scalpel and dig around in the wet stuff and see how they do the calculus, which is equivalent to opening up that algorithm and seeing how it works. No, what you're going to look at is the inputs and the outputs. And you're going to make sure that what they have done with the inputs, what the results that they have produced from those inputs, are appropriate and are correct, and that they perform well on their exam. And the rest is easier than you think. The tools are getting better and better. Easier and easier. You don't need a PhD in computer science to participate in this space. And cloud providers like Google Cloud are here to help you. What you are responsible for is figuring out what's worth doing and what it means to work and how you check whether it has worked. And the rest is putting your ingredients in, dabbling, tinkering, playing in the kitchen, where we make it really easy for you to bring your ingredients to your algorithms or appliances, if you will, and then go have fun, be creative. Your machine learning adventure awaits, so I hope that you're excited. I really am. I think that this is the future. I'm excited that we now have two ways to talk to machines. We used to only be able to talk with instructions, do this, then do that, then do that. Now we can get really complicated tasks done where we just couldn't say how to do them, but we could give examples. It's an incredible ungagging of all of us to be able to communicate our wishes in a much more powerful way. So I'm really excited. I hope you are. Thank you very much for your time.